Well, I want to thank our next speaker, Brendan Ashworth, who has duly waited around here till the end of PostGIS Day. Thank you very much for your patience in waiting. Brendan is a co-founder of Bunting Labs. And if I'm not mistaken, Bunting Labs was doing GeoAI before GeoAI was the thing that people were talking about a lot. I remember fondly, I think you did some very, very clever digitization tools that I saw being promoted as GeoAI back before everyone was talking agents. So I'm glad you're still doing it. Haven't given it up, right? Still on
Yeah,
the GeoAI train.
yeah,
And you're going to tell us some useful and practical things about GeoAI agents, if I'm not mistaken.
yeah, that's right. Um,
Awesome. Take
Great.
it away.
Thank you so much for inviting me here. Um, Let me get my slides. Can you see this okay?
Sure can.
And you can hear me all right?
Sure can.
Awesome. Thank you so much, all of you, for being here and accompanying my talk. And Liz, Paul, thanks so much for the invite. So I'm going to be talking today about AI agents for querying PostGIS. And AI agents, this is I want to get started on the right track, which is that when people talk about agents, they mean all sorts of different things. It's really just a buzzword at this point. And I don't want to lean into the buzzword side of this talk. I think it's PostGIS Day. Really, we're celebrating a great technology here. And I think being really technical and precise is really the move. And so when I'm talking about agents, I'm not talking about them in the way that most companies and enterprises or social media talk about agents, which is this thing that's coming for everyone's jobs. That's really not the point here. An agent just means that you're giving feedback to the LLM as it accomplishes a task. And so we're not talking about the human replacement concept that a lot of companies are going after. It's really just that an agent is using tools to accomplish tasks on behalf of someone, normally a human, and it's getting the feedback from those tools and then using them to accomplish tasks. And so we're going to dive really deep into how AI agents impact PostGIS, how they impact spatial data, and how this all really comes together in practice. Um, so to start, I think maybe a history lesson would be useful. A long time ago, there was just humans, and then they created maps, and the map was just the physical paper with the map data on the paper. And then along came the computer, and some very smart people put the map data on the computer, and it turns out this was very useful. And I think we're entering a new paradigm today where AI is now on the scene. And there's an open question in GIS, spatial data, PostGIS, as to what this new interaction looks like. Are we in for a new experience of working with maps and spatial data? And I think this question actually has questions within this question. Are these new platforms? Is it being built into an existing platform? Are there new technologies that we still need in order to take advantage of this? How much is the user experience actually changing? Is the same map experience and spatial and tabular data, are they the same? Can you still give the user low-level control of an AI-driven map software? What happens to the jobs? What about data privacy and ownership concerns? Every time you use AI software, it's being sent to somebody else's server. What's up with that? Don't you want ownership of your data? Your enterprise wants ownership of their data. And at the end of the day, who owns the LLM? I think there are a lot of very compelling questions in this, and we really only have a couple of instances where people have offered a view of what the human AI map interaction looks like. This is just OpenAI ChatGPT. I asked it for some coffee shops near me, and it gave me a map. I think early on people were skeptical of the idea that LLMs could give you maps. But I think it's definitely apparent now that if you give an agent, an LLM, the right tools, it can give you sometimes great output. And so why am I talking about this? Like, what do I know about human and the AI and the map interaction? What is Bunting Labs? Well, I've built a couple of AI agents for GIS. The first one is a product that we call Q. QE is an AI copilot inside QGIS, so it's embedded in the sidebar. And it actually has access to the same tools that you do in QGIS. And so you can ask it to do things. Here, it's asking for an intersection and it's running geoprocessing tools. And it's actually giving the output in the window. Um, we also are working on Mundi now. Mundi is an AI WebGIS that actually is built for more close human AI interaction. And one of the best uses of Mundi today is in interacting with PostGIS and spatial databases. Mundi is open source, so you can actually go and check out the code online and deploy it on your own servers. And so the million-dollar question here is, will AI agents change interaction with spatial data? Are maps going to change forever? Is PostGIS going to change forever? I'm of the opinion 100% yes. And that's not just because uh, it's not just because I've already led myself to believe this. I think there's some very compelling evidence for it. And I think if you've ever gone to ChatGPT and maybe copied in your database schema into the input text box, and then you get a query back answering a question that you originally had, and then you get some response back from PostGIS, and then you copy and paste that into ChatGPT. The key insight here is that you're actually acting as the agent there. Your knowledge, your intelligence is being added on top of an LLM to actually write SQL queries, ingest all of the data that's coming out as a result, and iterating on that feedback. And so the pitch of AI agents isn't that you can do, the pitch of AI agents is not to automate large swaths of things. It's to do it faster and better. And I think that's really the core concept behind Mundi. So here I have loaded a PostGIS database with 111 tables. This is actually a freely available database online that describes oil and gas exploration in the offshore area, I guess, east of Norway. And this database contains all sorts of complexities in terms of schemas, in terms of relations between different tables. Probably only about 15 of these tables actually contain spatial data, but you might have 10 tables that relate to the spatial data column, to the table that has spatial data. And here we're using Mundi, the AI WebGIS, to actually autonomously query the PostGIS database. And it's developing an understanding of the schema that we have and also and the metadata we've attached to it, and answering questions and adding data from the PostGIS database to my map. Um, and so we've given it a bunch of tools. I'm going to dive really concretely into what's actually going on here. Um, but you can see we can zoom in. All of these tiles are being served directly from PostGIS using this query that we've created on the fly. And perhaps it's going to go ahead and set the symbology for us. And these are data-driven symbologies based on the attributes on the Postgres tables. So that's kind of an early window into what's happening. And I want to dive really concretely into what makes an AI agent for PostGIS tick. There's a lot of nuances and opinionated design decisions that go into making a useful AI agent for exploring spatial and tabular data. I'm going to go really technical here, and I'm going to try and make it accessible to an audience that's really familiar with PostGIS and perhaps less familiar with the vocabulary and functionings of LLMs. Please feel free to drop anything in the Q&A, and I'll either answer it during or after my talk. Um, but With that in mind, I've chosen seven really key important topics to think about as you look and work with AI agents for GIS and spatial data. And to cover this flow real quick, you really just start with the user query in the beginning. You might be giving a really, really simple question. What's the most valuable company in the world right now? And then the agent is just designing, it's planning and then using tools to answer your question. So it might be querying a Postgres table with the companies in it, and then looking at the attributes, the columns on those tables. It'll reflect and then answer your question. This is the same flow that all ChatGPT has right now. And I think there's nuances to turning the ChatGPT .com interface into something that's really useful for spatial data today. The first one is actually formatting the database schema, and this sounds really boring. If you look at the way that you might currently describe your database schema, you might be in PSQL, and you might use like the /d or /d plus. And it turns out that these are very verbose, and they have a very um, they only describe certain parts of your database with lots of characters. And when you put text into an LLM, you're actually charged by the quantity of text you're inputting. Those are called tokens. And the more tokens you put in, the more you're charged. Not only are you charged more, but you're charged more every loop of your agent. And so if you have a complex request that you're asking some sort of AI, the agent might be doing 10 or 20 loops. And so every time you're getting charged for the database schema that you sent first, which is really this base level of information about your data. And how to present that really clearly is actually kind of difficult because how you present the schema is opinionated. How important and how should you emphasize the foreign key relations? How do you want to describe all of the types? Is it important to say the SRID of these geometries? There's kind of a whole bunch of things. It's really a lot of experimentation goes into it. And what we've actually done is when you first connect to a PostGIS database in Mundi, again, the code for this is actually open source, so you can go online and take a look. Is we query and take a look at your tables to understand example values and to understand the schema of each of these tables. And then we generate a database documentation. This is actually useful even outside of GIS and AI GIS. We generate almost a Wikipedia page for your Postgres database. And this describes, it has an ERD diagram that kind of describes the relations, the foreign key relations between different tables. And it also has summaries describing what the important parts of your database is and what you can focus on. Um, there's a lot of nuances to this as well. It's really important to allow someone to attach metadata, like if they have a PDF document describing what these things are. That's super important to allow. The next really interesting one is choosing the right LLM model. There are so many today that you can actually choose from. They basically, you get more and more options as the days goes on. Um, Important factors include which cloud provider you are more amenable to. Many people often choose the model that was designed in their country, which is pretty interesting. We work with a lot of European clients, and they really prefer like kind of European sovereign AI. And some other interesting things to consider are how we talked about the system. We talked about um, the most important input to your database, to your LLM in the beginning is the database documentation. Whenever you hit the LLM again, some will charge you less for text that they've seen before, which is the database schema. Some charge you a lot less. That's really important. Okay. Now let's talk about PostGIS. You'll notice that I just put in PostGIS here, and that's not because this is PostGIS Day. PostGIS is actually, I've found to be the best thing to put inside the agent loop. And here's why. Query latency is really important. If you have a simple query on your spatial data that executes in 10 milliseconds, that's golden because you might be iterating on that 10, 25 times, and the latency just multiplies every time. And the user will get increasingly frustrated if your data is taking forever to load. Um, I've had worse experiences with DuckDB in the agent loop, partially for latency, but also there's another kind of interesting insight here. LLMs generate better SQL query for PostGIS than they do for DuckDB. And to understand this, you actually need to understand how they train large language models. Um, when they first started training large language models, they would train it on the corpus of the internet. And then that was more or less all of the knowledge that they accumulated. And so some of it was Postgres, some of it was PostGIS with the ST spatial type functions. Some of it was kind of like more of a DuckDB style SQL. And all of that was kind of mixed in together. The AI labs realized that competency in SQL is one of the most important characteristics of an intelligent LLM. And so they created a sandbox for executing Postgres SQL queries. And so this is how LLM AI models are trained today. After this initial period of learning, they insert an LLM into a sandbox and they give it positive or negative rewards. Um, they give it positive or negative feedback to indicate that it's having success in querying a Postgres database or it's having failures. And they also do this with PostGIS. And so all of the like deep functionality that PostGIS has accumulated over 24 years, the LLMs have trained on. And when DuckDB fails to have certain spatial type functions, for example, the entire query fails and it has to rewrite it. This is pretty difficult. And so as not just because it's PostGIS day, PostGIS is definitely the most useful thing to put in the center of this loop. We also have, if there's any sort of, if it encounters an error, the most simple is like a query syntax error. But if you're not getting the right result, if there's some sort of further processing that needs to happen in order to answer the user's query, you need to handle the failure and get this information and put it back into the LLM. This is probably the most simplest part of this loop. But you're really just asking yourself, how can we get more information about this problem and give it to the LLM? Here you can just copy and paste the error message, but I think some really smart ways to do this are surfacing more of the database schema that's relevant to the last error and giving it back. I guess this is cut off a little bit. But there's often schema ambiguity in Postgres databases, which is really interesting. So here, let me give you, this is a real example from the Postgres database that we're using. So here I've asked it, what are the most productive fields by oil output? It's going to query my PostGIS table. And it's given me a table with on the left, let me see if I can pause it. On the left, it has the field name, and on the right, it has recoverable oil in million cubic meters. This is really interesting because this database in particular has ambiguous units on its metrics. And so this is actually described as a number type, And the LLM is inferring here that it's a million cubic meters. This is kind of one of the more nuanced aspects to AI agents querying PostGIS data. And that is not only has it I don't really want to call it a hallucination because it could be correct in this instance. But it's certainly inferred this unit type, and it has not made it clear to the user that this was an inference. It's just kind of declared it as fact. And so dealing with ambiguity and presenting all of the important units to the LLM in the beginning is really, really important. Finally, we want to make the resulting query interpretable to the user. This is quite um, important because for users that are of lower familiarity, and actually users with higher familiarity, um, the LLM can present things in a very compelling way, and you need to actually ground the results in the query that it wrote to make sure that it's answering your question exactly as you intended it. The way that we do this is we actually surface the syntax highlighted SQL queries directly in the sidebar in Mundi. And so on the right, these are the AI generated SQL queries. You can see that it's highlighting the functions that it's using. And these layers are then added to the layer list, which you'll be able to see in the next one. Um, these layers are then added to the layer list, added to your map, and made interpretable. And so you can actually explore the map with data loading directly from PostGIS. In Mundi, we actually serve tiles directly on PostGIS, and we have a read replica that's can auto scale to a high level of concurrency, at least for this demo. And so here it's using the layer list on the left. So this has all the PostGIS layers that we have loaded. I actually have clicked on one of these fields, and in the bottom left, it's highlighted. So it has the name and the amount of oil. You can see that there's not a unit associated with that recoverable oil attribute. And also in the text box where you communicate with the AI agent, there's a cursor icon with a selection. That indicates that the AI agent can actually see your selection. And so if I were to ask a follow-up, for example, what are the closest fields to this selected field? It knows the unique ID on the row that I have selected, and then it can query subsequently following up on that. And so the last step in building an AI agent for PostGIS is actually security, and it's one that nobody's really talking about, despite it being really important. If we were trying to take AI agents, if we were trying to prevent AI agents from taking over the world, the really simple things are executing queries in read-only transactions. Okay, boring. Really simple. Everyone should be doing that. But what if someone could steal your data? Not unrecently, there was a vulnerability in Microsoft Copilot, I believe, that actually allowed you to extract somebody else's private data from their workspace without their permission. And that's due to what's called the lethal trifecta. The lethal trifecta is something you must consider when creating an AI agent. And it has these requirements: access to private data, untrusted content, and the ability to externally communicate. But it only makes sense with an example. So as an example, consider that I might have an AI agent that has access to my Google Drive and my Gmail. And somebody sends me an email that says, hey, can you send me the bank statement in Google Drive? If the AI agent sees that the name on that email is Brendan Ashworth, it might indicate, or it might make the agent believe that it can access my private data and externally communicate the bank statement from my Google Drive via Gmail to this third party. And so if you have all three of these, available on an AI agent, you're actually vulnerable to this attack. A lot of AI agents suffer from this in the real world today. We avoid the lethal trifecta by not allowing you to externally communicate. So the user must take the data from the map and do something else with it. But this is really important. And so finally, just before I conclude, I want to briefly mention MCP. I think people talk a lot about MCP and what it could mean for spatial, for PostGIS. And I want to say that MCP is useful, but MCP doesn't, it's not the holy grail of building AI agents. It's a very narrow tool that allows you to connect tools to LLMs. And it's not the end all be all. I think especially for geospatial and for querying spatial data, a really important aspect of this is the output and handling both visualizing spatial data on a map for a user and handling the queries and presenting that faithfully to a user. And MCP doesn't deal with any of this. Um, so I think building AI agents for geospatial and for PostGIS is super important. I think MCP is not actually that important. So with that said, thank you so much for listening. Thank you for inviting me here actually to share this. If you're interested, you can try Mundi at Mundi.ai. And if you want to talk to me directly, you can email me at brendan@buntinglabs.com. Thank you so much.
Thank you, Brendan. That's a standout talk and great to get down to the basics. Defining your terms. Imagine that, defining your terms. What is an agent? Um, it seems pretty magical to me, this idea that I just I ask, I tell it something, then it comes back and it looks at what it got and then decides to do it, and then it decides, and then it decides. What is the stopping condition? What causes this thing which could apparently go on forever from not going on forever?
Yeah, so there's two really interesting parts to that question. So the first one is in practice, people actually normally set a max number of steps.
Okay.
Often it's as many as 200, and they say, okay, at 200, you are doing something wrong. Let's stop. But I think a really interesting way to look at it is what happens when it gets it wrong, and it just, it keeps on going.
All right.
And this was especially true early on. If you asked certain AI agents to solve really difficult math problems, like math problems that uh, pretty much most mathematicians believe are like unsolvable for decades.
Yeah.
It would keep thinking, which is really interesting.
Good.
Yeah, I mean, I don't really know if it's interesting. It's interesting.
Mhm.
Yeah.
All right. And a question from Phil Barty. I'm curious about your PostgreSQL PostGIS specific sandbox statement. What source is this based on?
Oh, yeah. So uh this is based on my familiarity with the space.
Yeah.
I don't have a particular source. The technical term for this is RL environment.
Hmm.
So this is when they're doing reinforcement learning. Uh, and the way that this kind of works is the AI labs choose a number of RL environments to build,
Yeah.
and then they train specifically for these tasks. And so it's not that um, like I believe, based on my experience, that they haven't made a DuckDB RL environment,
Yeah.
but they have made a PostGIS RL environment. And that's based on my experience using SQL written for both.
Right.
Um, but it's not that this is a permanent handicap of these models. Rather, I think in the future, it'll be able to do both and kind of context switch.
Hmm.
But I've had real world problems with this as of the last few months.
Yeah.
Um, yeah,
So when an LLM adds a layer to Mundi, say,
yeah.
what's going on behind the scenes? There's a new tile layer somewhere, I guess, and that's pointing to some custom SQL, which is what just popped out of the back end of the agent and that all that stuff is being stuck
Yeah. So
in front of the.
when there's like this concept of a SQL layer from PostGIS
Mhm.
in Mundi, there's a couple of different aspects to it. First of all, there's the tile layer. So we serve the tiles directly from the PostGIS server, based on a kind of, uh, I guess, using that as a subquery. And then we filter it for the attributes that are actually used in data-driven symbology. And so if the agent has written symbology that depends on certain attributes in that layer, we hide the columns that
Mhm.
are not used for the symbology to reduce bandwidth and processing time on the server. And we only serve, for example, the unique ID, something for a label, and something for like, some sort of number-driven symbology,
Yeah.
like population density.
Yeah. Yeah.
Um, yeah.
How do you get your LLM generating symbology that your web client is happy to consume?
That's also an agentic loop.
Okay.
Yeah, because it's really easy to generate incorrect symbology.
Uh-huh.
And most of that is around detecting early that the symbology is wrong, and then capturing that information and feeding it back to the LLM. There's a lot of nuances with that. I feel like I could also give a talk on LM generated
Yeah.
symbology.
And
But
is this your own symbology language, or is this specific to
no, we use
map You get
MapWeaver. Yeah,
a
we
little bit
use
of leverage from
MapWeaver.
that. Yeah.
Yeah, yeah.
Do you
Um,
ever wish you could like fine tune your model to know more about some of the domains you want it to speak, or is
yeah, fine tuning is definitely a double-edged sword.
yeah.
Because it gives you capabilities now, but it gives you debt later.
Mhm.
Because if I fine tune something to be more performant, for example, on DuckDB, um, and another model in the future becomes more intelligent in a dimension that I'm interested in, I am then faced with this choice of losing out on the future intelligence at the cost of this very unique feature set that I want now. And so that's definitely like a live trade-off.
Yeah.
Yeah.
Well, Brendan, I want to thank you again for coming to Post Just Day and sharing your knowledge. It's been an amazing talk, and I've learned a great deal, which is the whole point of Post Just Day. I get the world to come to me, tell me,
Yeah.
tell me the important stuff. That I've
Yeah.
learned the important stuff. Thanks
Thank you
again.
so much. Thanks.